Welcome to the Science Minute. I'm Joey Friedman. The internet was recently rocked by a math question on a British standardized test that reportedly bewildered thousands of our young friends across the pond. This question is perfect for the Science Minute because first, we like to show that math and science are not that scary, and second, because the question deals with candy. The question boils down to this. Given a number of candies of various colors, what are the odds of drawing out a color that we like? And then what are the odds of drawing out a second of that same color? The technical term for this is probability. Probability is, given a total number of equally likely outcomes, how many of those outcomes do we like? Divide the first number into the second, that's the probability. For example, here we have 5 candies of different colors. What are the odds of drawing out the orange one? Well, there are 5 candies, so the total number of outcomes is 5. How many outcomes do we like? 1. So therefore, the probability is 1 over 5, 1/5. Let's say we have 2 orange candies out of 5. Well, number of outcomes is still 5. Number of outcomes that we like is 2. So the probability is 2/5. Okay, if we can go all the way up to 5 orange candies, the probability is then 5 out of 5 equals 1, a sure thing. Yes, in probability, you can have a sure thing. Going back to our example of 2 orange candies out of 5, let's say we do succeed in pulling out the first orange candy on the first draw. What are the odds of pulling out the second orange candy on the second draw? Well, how many outcomes are left? 4. How many outcomes do we like? There's only 1 orange left, so it's 1. So the odds of the second draw getting the orange are 1 out of 4. Then what are the odds of getting both orange candies? Well, we had 2/5 for the first draw, 1/4 for the second draw. We multiply those together to give us 2/20 or 1/10. The odds are 1 out of 10 that out of 2 draws, both of them will be orange. Why do we multiply them together? Good question. Look at this chart. The 5 rows represent the 5 possible draws from the first one: orange, orange, green, blue, and yellow. The 4 columns represent the 4 outcomes for the second draw: orange, green, blue, and yellow. The red area here represents the intersection of the successful columns and rows where we get orange on both. The area of this intersection is 2 by 1, which is 2. The area of the entire graph is 5 by 4, which is 20. So again, we have 2 out of 20 equals 1 over 10. The odds of drawing out 2 oranges are 1 out of 10. Not that scary, right? Before we close, this past week, the New Horizons probe flew within 7,800 miles of the surface of Pluto, making Pluto the furthest world in our solar system visited by an Earth spacecraft. A mere 85 years after American astronomer Clyde Tombaugh discovered Pluto, we have bridged the 3 billion mile gap between our worlds and are enjoying the travel pictures. Along with this being the 46th anniversary of man's first landing on the moon, this is indeed a landmark week in the history of science. If you have any questions you'd like to see answered on the Science Minute, send them to science@joeyfriedman.com and also visit us on Facebook at The Joey of Science.